So I ran out of time on the last video to be able to show you these last two examples of a percent increase and a percent decrease, but I did want you to have the work so that you could go through and make sure that you were doing them correctly. If you have any questions about these, you can feel free to reach out to me. In the interest of time, we're going to go ahead and move on into multiple percent changes. And multiple percent changes are exactly as it sounds. This occurs when you have more than one change in percentage. So instead of the discount being just 30%, it's a 30% discount followed by an additional 10% discount. And so a lot of people are tempted to go ahead and add those together and say, oh, well, that's a 40% discount. But we can't do that, and let's talk about why. So Cell Plus is running a 20% sale on their phone accessories. You also have a coupon for 30% off your entire purchase. What is the total discount rate received? Well, let's say we're buying $100 worth of items. The 20% off sale means that we'll be paying 80% of the $100 cost. And so what does that mean? That means we're going to be paying $80. Now, the additional 30% off coupon means that you're going to be paying 70%, but you're not paying 70 or you're going to be paying 70%, but not 70% of the original $100, but 70% of the $80 that's remaining. So notice that the basis changed, and therefore you cannot simply add the discounts. So a 20% discount followed by a 30% discount is not the same as a 50% discount. And it turns out that the way that we can calculate this looks really ugly, but it's actually not that hard to find. So if we look at the formula, we have all of these different R's, and we have R sub n and R sub n minus 1, and it's really confusing looking. But all this really means is that the R's don't have to be the same. So on the left-hand side of this formula, we're going to have 1 plus R, and then on the right-hand side, we're going to have however many sets of parentheses we need to represent each of the various changes. So in our previous example, where we had a 20% discount and a 30% discount, we would have two sets of parentheses. And what we're going to do is we're going to use the plus if it is an increase, and we're going to use the minus if it is a decrease. So let's look at a couple examples where we have more than one change, and we're trying to use our formula here, which looks really ugly, but we're going to see that it's really not that hard to use. So let's look at the first example. During January 2012, diesel prices increased by 1.9%. In February, they increased by another 6.2%. In March, the increase was 1.2%. But in April, they dropped 2.1, and in May, they dropped another 5.2. So what is the percentage change in the total price of diesel over the 5-month period? Well, remember, our formula, anytime that we have more than 1% change, our formula is going to be 1 plus R on the left. And on the right-hand side, we're going to have one set of parentheses for every change. So how many different changes did we have in this case? We had 5 different changes, so we're going to have 5 different sets of parentheses. So in the first set of parentheses, we're going to have our 1 because we always have 1. And then we have to ask ourselves, was the first change an increase or a decrease? Well, the first was in January, and it increased by 1.9%. So we're going to use the plus because that indicates increase. And then remember, any percentage we use in a formula has to be as a decimal, so 1.9 would be 0.019 in decimal form. So that represents our first percentage increase. Now we need a new set of parentheses for our second change, and again, it's 1. This is also an increase because in February it increased by 6.2%, so that would be plus 0.062. Now our third change, so we have a third set of parentheses. Again, it's 1 and it's plus because in March it increased as well. And it increased by 0.012. And now in April, notice that it dropped. So we're going to have a fourth set of parentheses, but instead of 1 plus, it's going to be 1 minus. And 2.1% as a decimal would be 0.021. And then our fifth change is also a decrease, so that's going to be 1 minus, and it's a decrease of 5.2%, or 0.052. And so now that we have all of our changes represented on the right-hand side, now we're ready to go ahead and solve our formula. So we're going to do what's inside the parentheses. 1 plus 0.019 is 1.019 times 1 plus 0.062, and we're just going to continue doing this until we do all of the operations inside the parentheses. Now be careful, these last two are subtraction, so we're going to have to take that into account. So we're going to do 1 minus 0.021 or 0.979, and then 1 minus 0.052, which is 0.948. Now that we have everything inside the parentheses calculated, we are ready to multiply them all together, and that gives us 1.016413073. So now we're ready to finish solving for r. Notice that on the left we still have the 1, so we need to subtract 1 from both sides. So we get that r is equal to 0.016413073, and remember that since we are dealing with r, this should be in percent form, so our percent would be 1.64% change, and notice that it is a positive, so that means it is an overall increase of 1.64%. So over the 5-month period, we had an increase of 1.64%. So again, the formula looks really ugly, but if we break it down, it's not that difficult to work with. So let's look at another example. We have a retail store received a new item, which they originally marked up for 40%. After it did not sell, they marked it down by 30. Since it still did not sell, they marked it down again by 25. What's the overall percent increase or decrease? So again, the fact that we've had multiple percent changes tells me that we are going to have to use our formula of 1 plus r equals, and now how many different changes did we have? Well, it went up 40, down 30, and down 25. So that's 3 total changes. So we're going to have 3 sets of parentheses. And the first one was an increase. It went up by 40% or 1 plus 0.4. The second one was a decrease, so it went down by 30% or 0.30. And the third one was also a decrease, so it went down or minus 0.25. So now we do what's inside our parentheses. So we have 1.4 times 0.70 times 0.75, we get 1 plus r is equal to 0.735. Subtract 1 from both sides, and we get that r is equal to 0.265, and notice that it is a negative 0.265. So that means that we have an overall decrease, because if you're doing multiple percent changes and it comes up negative, that's an overall decrease of 26.5%. So again, anytime that you have more than one change in percentage, always use our formula where we have 1 plus r on the left, and then on the right we have a set of parentheses that represents each percent change. So the last thing we're going to be talking about in this first homework set is the concept of simple interest. All of the things that we've looked at thus far have been a percentage where we are increasing or decreasing, or we're finding a percentage of a number. And now we're actually going to start getting into more of the bank type financial piece of it. So when you think of simple interest, you start thinking about things like loans or savings accounts. And it turns out there are 2 basic types of interest: simple interest and compound interest. And simple interest is when you have interest paid only on the principal amount. So in other words, it doesn't matter if you earn interest or not. That's not going to be included in the new interest calculation. So simple interest is the easiest to work with because the interest is simply equal to the principal, or the original amount of the loan or investment, times the rate times the time. And you'll notice that we have a few different options for formulas here, and that's because sometimes we're only interested in the interest itself. We don't care about the future value. And in that case, we're always going to use this top formula, where we can calculate interest as just principal times rate times time. However, sometimes we're going to be dealing with a future value, so how much is in the account sometime down the road, and in that case we have to use this formula of FV is equal to P, so the future value is the principal times 1 plus the rate times the time. And in this case, T is always given in years, so make sure if you are given time in something other than years, you have to convert it to years before you can plug it into your formula. So let's look at some examples here where we are using the simple interest formula. Suppose you invested $1,500 at 3.22% simple interest per year. How much will you have at the end of 2 years? Well, notice that we're talking about a future value here. We want to know how much we're going to have at the end of 2 years. So we're going to use our simple interest formula that involves future value. So FV equals P times 1 plus RT. The FV, the future value, is what we're looking for. The P, the original amount invested, is $1,500. 1 is always going to be 1. That's never going to change. The R in this case is the 3.22%, but remember, we always have to rewrite that as a decimal. So 0.0322. And then our T is our time in years, and it's at the end of 2 years. So our T would be 2 in this case. So now we just have to make sure that we follow the order of operations and do everything in the correct order. So first thing that we're going to do, if I can get my equals here, is to do the multiplication that is inside of the parentheses. So we're going to take 0.0322 and multiply by 2, and that gives us 0.0644. Next, we're going to add in what is inside the parentheses. So 1,500 times 1.0644. And now we're going to multiply 1,500 times 1.0644, and that gives us a future value of $1,596.60.